Okay, so the first property you really need to know is density. Now that's whether something sinks or floats. Now in this case, we're gonna be using water, but it does not necessarily have to be water. There was a question about maple syrup, and they put stuff inside maple syrup. Now if it sinks, it's more dense. So if it sinks here, it's more dense than water. If it sinks in maple syrup, it is more dense than maple syrup. If it floats, it's less dense. Okay, so let's try some of these objects that we're gonna be working with, and we'll see whether they float or sink and whether they're less or more dense than water. Okay, so to measure density, you need water to see if it sinks or floats. I was looking through my house and I found a couple objects, regular objects that you can probably find at your house. I don't recommend you doing this at your house though, without parent permission. I don't want you telling them, Mr. Leal, let me do this, and you're just putting stuff in your bathtub full of water, stuff like that. You're ruining stuff. So please ask for permission first, but if they do let you, it'll be a great way to study at home without the computer. The first object I found were some paper clips on my desk. Now let's see what happens when I drop them in water and they sink to the bottom. That means they are more dense than water. Now if I get, I don't know, the bottle opener I found in my kitchen, let's see. That one also sank, which means it's also more dense than water. So a question here could be, out of the three objects, the bottle opener, the paper clips, or the water, which one is less dense? And I'll give you about 2-3 seconds to answer that. Think about it. So if the paper clips fell to the bottom, and so did the bottle opener, that means they are more dense than water. So in this case, out of the three, the one that is the least dense would be the water. Now, for example, if we do, I don't know, a plastic bottle, this is less dense than water because it floated. So out of the four, the one that is least dense is the Coke, or the plastic bottle. Now let's try an eraser. That one sank to the bottom. What about a knife? That one also sank to the bottom. Coke bottle. That one looks like it wants to float, so probably if the Coke wasn't in there, it wouldn't be as heavy, so actually the aluminum can would float. A nail, a wrench, a lock. Let's try the magnet. Sank to the bottom. What about the brass screw? Also sank to the bottom. So far, only one thing has floated, and if the aluminum can was empty, that would float too. But let's try this rubber glove. Take this one out. So that one is actually floating also. So rubber, the aluminum can, and the plastic all floated, and they are all less dense than water. Everything else I used and you heard about is more dense than water. All right, so we just did density with solids, but you can also measure density with liquids and just liquids. So we're actually gonna try that right now. Right here in these beakers, you have water with purple food coloring. So it's just water, and I'm gonna put corn syrup in one of them. So let's see what happens. Okay. So if you notice at the bottom of the beaker, and I'll lift it up a little bit, the water is still here, but because it is more dense than the corn syrup went all the way to the bottom. It didn't mix, it went straight through to the bottom and it settled. Now, yes, the colors are mixing a little bit, but the important part is right here, this line of division. Now, if I put some regular ice in there, So we have three things in there. We have water, we have ice, and we have corn syrup. Now, the one that is the least dense would be the ice because it's at the very top. The one that is the most dense, has more density, is the corn syrup at the very bottom. Now let's try something with this other beaker of water. So it's regular water, like I said, but now I'm adding normal vegetable oil, cooking oil, what your parents probably use to cook. Okay. And I'll put in some more. Lift it up so I don't make a mess. Okay. You can see that in this one, the cooking oil didn't go all the way to the bottom. It actually stayed on top. And that's because the vegetable oil or the canola oil that you can see right here, the cooking oil, is less dense than the water. So over here, this is the most dense, then the water, and the ice is the least dense. But in this case, the water is the most dense because it's at the bottom, and the cooking oil is the least dense because it's at the top. Now, I have seen questions, and some students have had difficulty with this. So what happens if we combine both of these into one container? So let's see what happens. And because it's wider, maybe we can't really see the maple syrup, so I'll just add more. You can kind of see at the bottom that it is settling. So let me just add some more. Okay. And then I'm gonna add more ice because that one is melting. And we'll talk about melting in a little bit. And now we're gonna add this. Again, it's water and cooking oil. Okay, I don't wanna overfill it, but I'll add some more cooking oil just so we can see a little bit better. So in this beaker, you see that the most dense is the corn syrup, just like in this beaker over here. Then it's water. Then it's a mixture of the ice and the cooking oil that are the least dense. Now, they might have close to the same density, but if you see it from the top, some ice is actually under the cooking oil and some ice is above the cooking oil. So they have about the same density, but I would say that the cooking oil has less density than the ice, because let's see. Okay. So we combined both beakers into one and the density remained the same. The most dense was the corn syrup, then the water, and then the ice and the cooking oil were at the top, so they floated. The one that sank was the maple syrup, the one that floated were ice and cooking oil. So even if mixing the both, it doesn't change the density. They will still separate. The least dense will always go up and float. The most dense will always go down and sink.